Alright, let's look at the homework 2.5, problem number 8. Alright, so we want to find the values of a and b so that this piecewise defined function is actually continuous everywhere. Alright, so when you look at it, you can see that this is a rational function which is continuous on its domain. So x is less than 2, so it's in the domain, so this is continuous by itself. And the middle one is a quadratic function, which is continuous everywhere. And also the last one is a linear function, so it's continuous everywhere. So these formulas by themselves are continuous. The only problem that could occur is the gap between two different formulas. For example, x equals 2, it changes its formula. And also x equals 3, it changes its formula. So we have to make sure that it is continuous at 2 and also continuous at 3. Alright, so let's do that. Alright, so we want to make sure that this function is continuous at 2. I want to make sure that the limit of this function, f of x, right, as x approaches, say, 2 from the left, right? So if you want to evaluate that, you can see that the formula is x squared minus 4 over x minus 2 for x is less than 2. So we can evaluate that. So x approaches 2 from the left. So I'm going to actually go ahead and factor it out. So x squared minus 4 can be written as x minus 2 times quantity x plus 2, right, divided by x minus 2, right? Then we can cancel x minus 2 and x minus 2. And then plug in. So we plug in 2, so it's a 2 plus 2. So that will be 4, right? So we have that. Alright, then this has to be the same value as f of 2. So let's find f of 2 first. So f of 2 would be, alright, since 2 belongs to this interval, 2 is included here because of the equality here. So we have to use the second formula. So plug in 2 here, 2 squared, so it's a 4a. Alright, and put 2 here, negative 2b plus 3. Right. So by making sure that these two values are the same, we can get an equation involving a and b. So we know that it has to be 4a minus 2b plus 3 must be equal to 4, right? If you want, I can probably subtract 3 from both sides. So we have this equation 4a minus 2b is equal to 1. Right? And we can do the same thing at x equals 3. So for example, if you look at the limit of f of x, right, so as x approaches, say, 3 from the negative side, right, so if that's the case, we need to look at, let's see, x approaching 3 from the negative side. So we still have to use the middle formula there. So you have a x squared minus bx plus 3. Alright, so then you basically plug in 3. So 3 squared, so you have a 9a minus 3b plus 3. Right? Then if you look at the f of 3, alright, would be plugging 3. So 3 belongs to this interval. so we have to use that. So it's going to be 2 times 3 is 6 minus A plus B, right? By setting these two guys equal to each other, we're going to get this equation. So by putting those equal to each other, actually I'm going to go down here. Alright, so you have a 9A minus 3B plus 3 is equal to 6 minus A plus B. Alright, so I'm going to put all the A's and the B's on the left and the number on the right. So I would add A so that I can move this guy to this side, and subtract B so that I can move this guy over to the other side, and then I'm gonna move 3 to this side, so I'll subtract 3. Alright, so what you get is going to be 9A plus A, so you have a 10A. Right, and the negative 3B and the minus B, so minus 4B, right, is equal to, right, 6 minus 3, so it's going to be 3. Right, so we have that. So we have these two equations. So we have this is the first equation here, and this is the second equation. Right. So let's try to solve this one. Right, so I need a little bit more room. I'm gonna actually go up here. So we have 10A minus 4B is equal to 3. Right, so I'm going to actually multiply this equation by 2. So you have 8A minus 4B is equal to 2. Right, then we can go through a subtraction. Right, so you have 8A minus 8 would be 2A, and negative 4B minus negative 4B is 0, and then you have a 3 minus 2 would be 1. Right, so you can see that by divide through by 2 we can get A to be 1/2. Right, so once you have that value, we can just plug in. So I would probably plug this guy into whichever equation. I'll probably plug it into here. Alright, so that way you have a 4 times 1/2 is 2 minus 2B is equal to 1. Alright, then we can just solve. So subtract 2. So negative 2B is equal to negative 1, and then divide through by negative 2, so that the B is also 1/2. Right, so A is 1/2 and B is 1/2. Right, so let's type it in. Right, we found that to be 1/2 and also 1/2. Right, so let's submit for testing. Alright, it came back and looks like we got these ones correctly. Alright, that's it. I hope that this was clear.